Hello student, our topic is a Huffman coding problem solving. Means a problem is there, so using the Huffman coding we can calculate the code word of each and individual letter. So you know the Huffman coding is a lossless compression type of coding. So in the lossless compression, a file can be restored to its original form, as well as no quality degradation happen in the lossless compression. So using the Huffman coding, we are calculating the code word of the all the letter from A through F. So the question is, a document contain letter from A through F with the frequency as indicated. So there is some frequencies there. So using the Huffman coding, derive the Huffman tree and as well as calculate the code word set. This is given the question. The question is given in your examination 2013, and the same question is repeated with the variation of the value. Now the solution, as per the note given and the steps are given, the solution is like that. So first, whatever our parameter or the each letter individual frequency is there. So according to our table, first we make a mean heap. Mean heap means we are making a ascending type of table and we are arranging all the frequency in a ascending order. So arrange all the letter A through F in the ascending order, or we can make a heap. So first F is come because the frequency is F is a 0.4, and ultimately in the ascending order we can arrange all the letter. Now step 2, extract two minimum frequency node from the mean heap and add a two internal node with the frequency. So we are extracting first minimum two frequency, that is a F and B, which hold the frequency 0.04 and 0.01, and we just add up these two frequency and make a single internal node with F and B. So we are adding the value 0.04 and 0.010 and it will become 0.14. So we make a tree of the internal node 0.14. Now when it is done, the value is 0.14. For 0.14 is a new internal node with a frequency 0.14. Now we arrange the character as well as its frequency with the ascending order. So see the internal node, the 0.04, next the frequency D 0.15, C 0.20, A 0.25, E 0.26. Same procedure again, go extract two minimum frequency and form the mean heap. Now this time the minimum frequency is the internal node frequency, the 0.14, and D, that is a 0.15. We are added up these two number and we got the 0.29. So according to the value we are making the tree. The 0.29 is the internal node. Internal always indicated by the oval sign, and normal leaf node is indicated by this way. This is the rectangle shape and the character with this frequency. Again we arrange the frequency in the ascending order. So C, A, E. Next is the internal node. This is the highest value, is the 0.29. Now step 4. Again extract two minimum value, that is a 0.20 and 0.25, and added up the number and make a new internal node. So we are adding the number and make the 0.45. Now the value of the now internal node is a 0.45. So based on 0.45 we are making a tree, as because for the 0.25 this is the internal node and C and A are the new node. There is no internal node, so tree will be like that. So 0.4 is a one left node and the right node. Again we are arranging the character with the frequency in the ascending order. Now we got the one single character is there, it's a E, and two internal node is there. Now again we extract the minimum frequency from the table and added up the value. So 0.26 and 0.29. So 0.26, 0.29, it becomes 0.55. So 0.55. So in the 0.55, one is the internal node and one is the E. See, one is a E and another is an internal node, that is a 0.29. Again 0.29 is making up the one internal node, is a 0.14, and one distinguished node is a D. Again 0.14 is making up the F and B. Now we are again arranging the value. Internal node was the 0.45 and new internal node value is the 0.55. We are making in the ascending order. Now the extracting the two value is a 0.45 and 0.55. We added up the value, so 1.00. Now make the whole tree based on that value. This is our internal node 1.00. 1.00 is make up the two internal node, that is a 45 and 55. 45 is making of the C and A, and 55 is making of the E. Here another internal node is a 29. Again 29 is make of the 14 and D, and 14 ultimately is made up of the F and B. Now put all the left edges, put the value 0, and all the right edges put the value 1. Now our tree is done. The first question, the Huffman tree is done. This is our ultimate tree. After making the tree, you have to calculate the code word for each and individual character or letter. So when code word actually calculated, how the code word is calculated? So first you have to find the letter A. See here letter A from the calculating the root node. So we just traverse from root node to node, the leaf node A. So first edge is a 0. So traverse, so from the root node it will traverse 1, and next after reaching the 45 it will again a single edge is there, is a 1. So the code word of A is equal to, you are calculating from the root node, is a 0 1 0 1. Now B is calculating over here. So we are starting the root node, so 1 1 0 0. So value is 1 1 0 0. Now C, root node 0 0. C value is a 0 0. Now D is a 1 1 and 1. So D is done. Now E. So why is E? So E is here for calculating from the root node is a 1 0, and ultimately the F value is a 1 1 0 0. So in this way we can solve the problem of the Huffman, creating the Huffman tree, as well as we can calculate the code word of any Huffman tree.